Okey, Assalamualaikum. Okey, untuk kelas hari ini kita akan tengok vektor. Sebenarnya kita akan sambung perbincangan kita berkaitan dengan vektor. We will continue our discussion on vectors. First we must know what is vector, classical vector. Okay, vector is a quantity that has magnitude and direction. Clear. Second, we learn how to find the component form, magnitude and direction of vector. Sebab component form, kalau anda tengok, dia dilahirkan daripada vector ni berkaitan dengan component form. Right? Apa yang dimaksudkan dengan component form? Ideanya adalah katalah satu vektor ini, this is tail and this is tip, ekor dan kepala, dan kemudian kita buat dalam bentuk right angle triangle. Yang ni kita panggil sebagai horizontal component, ini kita panggil sebagai vertical component. Kalau vektor ini komponen dia adalah, let's say this is vector V, yang mana this is tail, this is tip, ekor dan kepala. Maka katalah sini komponen X dia adalah 2, komponen Y dia adalah 3. Therefore dekat sini 2 ni bermaksud sini, 3 ini bermaksud tinggi dia. Okey. Begitu juga sebaliknya, boleh juga ditulis dalam bentuk menegak. Maksudnya idea dia, vektor ini akan bergerak daripada tail to tip. Tail dia bergerak ke kiri 2 unit, kemudian bergerak ke atas 3 unit. How do you know it moved to the right 2 unit, it moved to the top 3 unit? Because this is positive, this is positive. Let's say we have the second case here. Let's say we have S, the vector S equal to let's say the component is -2, 3. Okay, graphically means that this is X and this is Y. As -2, the vector move to the left 2 unit. Let's say apa ni, kita ada yang kita panggil sebagai vektor kita -2, 3. Dia bergerak ke kiri 2 unit. Katalah yang ni 2 unit. Kemudian dia naik sebanyak 3 unit. Ni katalah 3 unit kan. Ini adalah komponen horizontal component and vertical component. Therefore the vector is here. This is the vector, which is the vector can be described as a component as -2, 3. Right? Dapat? Okay. Ini adalah idea bagi component form, magnitude and direction. Kita dah tengok hari tu. Jadi magnitude ni apa, direction ni apa? Magnitude ni bermaksud, kalau contohnya kalau saya ambil balik yang atas ini, bermaksud magnitude ditulis dalam bentuk V lah. Distance. Ini distance. Ini akan jadi, we use the formula, distance formula, 2 square plus 3 square equal to the square root of here we have 4 plus 9, which is 13. Jadi jarak ini adalah sebanyak punca 13, ataupun kalau punca 13 ni dia setara dengan berapa? Saya tak ada kalkulator. Punca 13 dia lebih kurang 3.6 unit lah, because we do not use any unit centimeter or millimeter, then we just describe generally as a unit. Okay, clear? Yang ni yang kita bincangkan sebagai magnitude. And how about the direction? Okay, the direction of vector, let's say here we have the axis. Alright, here we have the axis, the y-axis and the x-axis. Okay, direction of this vector is the vector to the positive x-axis, the theta. How do you want to find the theta? We can use the tangent, which is tangent theta is equal to bertentangan 3/2, where theta will be inverse tangent 3/2, and approximately 3 divided by 2 inverse tangent. Okay, make sure that when you want to calculate the degrees, you have to change it to degree first. To the degree first. You do it back, change the mode to the degree mode. Okay, back 3 divided by 2 inverse tangent, then it will be 56. Approximately it is 56.3 degrees. Alright. Okay, next, if we refer back to the notes, okay, let's say we do the first example. Find the component form and the magnitude. Find the component and magnitude of V that has initial point 4, -7. The first point, and the terminal point means that the final point or the second point is -1.5. Hence, find the direction of the vector. And for sure, how do I to find a vector of 2 points? Maksudnya from point A to point B. Let's say this is point A and this is point B, because this is the terminal point, right? We can assume something like this. The initial point, let's say we have A for -7 and B is -1, 5. Okay, the vector from A to B, the vector that describe the journey from A to B is -1 -4. The second point minus to the first point, 5 minus -7. Okay, for the vector, we write inside the curly bracket, the sharp bracket, and here we have -5 and 13. Right? That's how you get -5 and 12. Oh, sorry, it's 12. It is 12. Okay. If you draw the vector, let's say this is x, this is y component, x component, -5, let's say we assume it's here because it's negative. The x component negative means that we move to the left. Okay, and y positive means that we move to the top, 12 unit. Therefore, the vector is, this is the location, this will be the vector that described from these components, right? Here, finding the direction of tangent theta, magnitude, we take the distance formula, and then it's equal to 13. Finding the direction of V, tangent theta, you can take the positive first, okay? And then we know that the negative, the tangent will be negative in second quadrant and third quadrant, right? And fourth quadrant, tangent, yes, the fourth quadrant, okay? Okay, the unit vector, right? What is the unit vector? We discussed this in class. Let's say we have a vector, let's say in our previous discussion, we have this vector. We use this vector, right? Let's say we have the vector 2, 3, which is 2 unit to the left, to the right, 3 unit on top. This will be like this. Okay. Let's say this is the vector V. Vector V is equal to 2 and 3. Okay. What is a unit vector? Unit vector is vector that has magnitude of 1. However, for this vector, the magnitude is square root of 13, the square root of 13, or is equal to 3.6, okay, approximately. Therefore, the magnitude of this vector is 3.6, it's not 1. How about if the magnitude is 1? Therefore, the vector will be approximate this long, right? Logically, we will have a more shortened component, right? Then how to find the component which is that will give us the magnitude of the vector which is 1? The idea is the unit vector will be with V, unit vector with V will be V over the magnitude of V. Here we have, what is the magnitude of V? We know that it is, this will be equal to the vector V multiplied to the vector V, and here we have 1 over 13 multiply, what is the vector V? Vector V is 2, 3. Okay, approximately we have 2 over square root of 3 and 3 over square root of 13, right? Or in you do not have to convert the fraction into decimal. However, I just want to show you the decimal point for better for us to understand the situation. Let's say we have 2 over the square root of 13. It should be approximate 0.6. 3 divided by square root of 13, it will be 0.8. Okay, here means that the unit vector to the V ataupun with V will be 0.6 and 0.8. Okay, this will be the unit vector. Right. Find a unit vector in the direction, this is the formula. For the opposite direction, the unit vector, let's say the opposite direction, the new vector, let's say M, that we can found by taking negative, because the opposite direction means that we just have to put negative, okay, in front of the unit vector, to the unit vector, negative. Find a unit vector in direction of U, in the direction of u and verify the result that has of magnitude 1 in the direction. Find the unit vector in direction of u. In other words, in order to find the unit vector, actually we must depends to one vector. That's why in question it will give you a vector. The unit vector must depend to one vector given. Okay, in this case it must be given. When it give u, here is u, and how to find the vector? It will be sorry. It will be u divided by magnitude of vector u. That's how we get here. Okay, you have to do some correction. The vector here, we do the calculation by taking x component as -2. Actually, here u is typo, right? -2 and 5, right? And then we calculate the unit vector. Then let's say you have the unit vector. How do you want to check the unit vector is correct or not? It's very easy. You just find the magnitude of the unit vector and the result must be 1. Okay, because it back to the definition, and unit vector is a vector which has a magnitude of 1. Okay, there's one question of unit vector given the vector a for I minus j plus k. This is in standard basis form. Compute a unit vector that is parallel, and for sure, in order to find unit vector, it must be parallel. When it's parallel, it can be in direction or in opposite direction. If it is, let's say the unit vector that we want to find is in opposite direction, means that you have to put negative in front of the unit vector in some direction of A. Okay, that's why we have here. Because in this situation, we have in the same direction. That's why we just take the formula directly. Okay. There is a question. Let's say given the vector A for I minus j plus k, compute a vector that has, let's say that has the magnitude of 7 and in opposite direction. Kalau in opposite direction means that you have to put the negative in opposite direction, the unit vector which is in opposite direction, berlawanan. Let's say, and that has magnitude of 7. We know that the magnitude of unit vector is 1. If the question 1, the unit vector that has magnitude of 7, then you just multiply this with 7. Therefore, we have negative 7, negative because the opposite direction, 7 because the magnitude, the question 1, the unit vector has the magnitude of 7. Alright.